Hi, I'm Bob from Hauptwerk Hardware, and in this video we're going to take a look at this. It's the Hauptwerk Hardware System 1 auxiliary board, and the idea of it is that it just provides the last few functions that are not available from all of the other System 1 boards. Also, we'll be taking a very quick look at this, which is the little 7-segment display board that works with the auxiliary board. So let's get them on the bench and see what they do. I've got the auxiliary board on the bench now, along with our little 7-segment display board. So just want to have a very close look. The first connector on here is our normal RJ45 type connector, which we connect it to the main System 1 control board with. We've seen this board many times before in the previous videos if you've been following along, and this is just a little Cat5 type cable that we're going to use to connect it to this board. The socket at the end here, which just about shows up I think in the camera, is marked as aux board, and that's where we plug this into, so that's all pretty straightforward. But I'm just going to move that out of the way for a minute. So the first difference is that this only has one RJ45 connector on it. All the other boards have two because you can daisy chain them together, but you can't daisy chain the auxiliary boards together. The idea being there that they're not really something that you're going to need or want to have a lot of. The whole point of the board is just to kind of provide the last few what shall we say, functions that aren't provided by other boards, shall we say. So things like with the 7-segment display, being able to give feedback for the user as to which capture system memory level they're on, for example. And there's a bunch of LED outputs around the side, so if we need some extra LEDs for something that wouldn't be provided by one of the other boards, then this is where excuse me, this would come into use. So for example, if you had a crescendo control and you wanted to have say 6 or 10 LEDs for that, then this would be the board to use, because there aren't really any other System 1 boards that would be suitable for that. I guess you could use a lighted piston board, but there wouldn't be a lot of point because half its functionality is not going to be used in that scenario. So this just provides a little bit of extra help, shall we say, for the extra bits and pieces that you might need in your organ console. So we've got 40 LED outputs around the side here, and we've got 8 inputs down this side arranged as like a bus arrangement. So basically if you connect any one of these inputs to +5 volts, then that will generate a MIDI output. All of the MIDI for this board is on MIDI channels 11 and 12. 12 is for this really, and everything else happens on channel 11 on here. So we've got a little socket here, the normal 16-way ribbon cable type sockets, and we have a little 16-way ribbon cable, and the idea of that is that we have the matching socket on the back of the 7-segment display. So we can just plug these two together very, very easily, which we'll do in a moment, and we'll have a look at how that works. The outputs along the bottom for the LEDs along the bottom 1 through 16, the reason that they're along the bottom is so that we can differentiate them from the rest. And the reason that we want to do that is because if we use the 7-segment display, then these outputs are actually in use then by this socket to drive this display. So you can't switch those on and off separately. So that actually uses 16 of the 40 LEDs that we've got available. But generally that's not a problem, because you don't, I've not come across a situation yet where I've needed to use 40 LEDs or even 24 and the display. As I say, it really is just for sort of mopping up the odd functions that the other boards don't cover. So basically I'm going to plug this into here. Channel 11, as I said, is the main control for this. So the way it works is if we send a MIDI note on 1 on channel 11, then this LED output will become on, and if we send a note 2 on, that one will come on, so on all the way around to 40. And when we send note offs for the same notes, obviously they'll go off again. If we connect any of these to plus 5 volts, then this will send a MIDI note on from 1 through 8 or 0 through 7. When we look at the computer, it always displays it that way, and that will also be on channel 11. And then channel 12 is what we'll use if we want to send data to light this display up. So basically, if we send a note on channel 12, this will display the note number. And it only works, obviously there are 2 digits, so it works between 0 and 99. Anything above that just gets ignored. So we'll have a quick look at that actually in operation. There's not really any configuration we need to do except for one link on this board here, and that's this one at the end, where if I can get the thing so it's not reflecting the light, here we are. So it says 7 seg, and then they've got this blue jumper. In the rearward position, that enables this display, so these first 16 outputs will not work when we send note on-offs to them, but when we send data on channel 12, this will display it. And if we move this jumper into the frontmost position, then anything we send on channel 12 will not work, the display will not light up, but these LED outputs we can send the data to on channel 11. If you have the display connected, when you send those on channel 11, obviously random segments of this are going to light up because it's kind of shared outputs, as it were. So it's one or the other, hence the little link at the back. So I've got it set at the moment in the rearward position so that the display will work. So let's move that out of the way for a minute and plug in our interface. So the little green light comes on. We will plug in our display, so that's pops into there, and this one into here. And now all I've got to do is make it stay the right way up and hopefully make it visible against the light, which might be a bit of a challenge actually, but I'm sure we'll figure it out some way somehow in a minute. I think that's actually works slightly better like that, doesn't it really? Anyway, there we are. So that's that side of it. If we come over to the computer, having plugged that in, I'm just going to restart our session to the comms session to the controller. And what that does is that it makes the controller just rescan everything, including those options links at the back. So the controller now knows that anything coming on channel 12 we have to send to this display, and anything coming on channel 11, because we've got the board connected anyway, these LEDs will work and these inputs will work. So that's what that's about. So if we look at the computer, we've got the normal displays that we've seen on the previous videos. So on the right here, this is the serial monitor display from the control board, and on the left we've got the MIDI received from the controller and the MIDI sent to the controller, and then underneath all of that we've got our keyboard, which is currently set to channel 12. So first things first then, we'll look at the display. This is plugged in. It's currently showing 01 at the moment. This is quite difficult to see because of the light, but let's see how it looks. So if I just click a random number on the keyboard, so that's note 14, and it's the note on event that triggers this to change. So we can happily let go of that off of the note. So if I pick another one, for example, so note 36 is on. When I release it, the display continues to show 36. And that's basically how that works. So obviously that will count up if I run up the keyboard like that, and it'll go all the way up to 99. Anything above 99 will be ignored. And that's it. When you reset the controller, it always resets this to 01. And the idea of that is, rather than having it go to 00, if you have it set to 01, then that's quite helpful if you're using this to display a user memory level, because most users would see 1 as the first level rather than 0. So that's what that bit does. So leaving that for the moment, we've got our little test lead here that we've used everywhere else, and we'll just have a quick look now. If I connect 5 volts. We've got a couple of test points here, there's ground and 5 volts. If I connect 5 volts to one of these inputs, then we'll see on the computer that that sends or makes this send. So we do it to input number 1. That's made that send a note on 0 on channel 10, it says on there, which is really 11. And at the other end, it's going to be note on 7. And when you release it, note off. And obviously all the others in between. So that's how that works. The idea of that being, if you've just got another switch or some control left over, for example a transposer or something like that, then this is a way to get that data into your virtual organ nice and easily. Now, to look at our LED outputs here then, I've just got an LED on the end of a couple of test leads, so hopefully we can get this put somewhere reasonable that we can see it. So let's find ourselves first of all a good ground point, which is probably that one. Just make sure. Yep, okay, fine. So that's good. And if I now connect the positive of this to, let's say, we'll use number 17 because we're using the 7-segment display, so 1 through 16 are going to be controlling that. We can't control those from the computer, so let's go hook on to number 17. So at the moment the LED is out, but if we come across to the computer and we change our little keyboard here now to channel 11, and we count up 17 notes, so we got there 12, 13, 14, 15, 16, 17, that's that one there. You can see the LED lights up, and when I release it, it goes out. And if I do it on any of the lower notes, nothing happens to the display. You get all this stuff coming up on the serial monitor here, but it's not actually going to make any difference because the display is enabled. So obviously all those notes in between work, and if we connect to number 40, which is going to be 39 on here, so we've got 12, 24, 36, 37, 38, 39. No, is that 40? That's 40. So there we got 39, which is, yeah, okay, 40. It's that add one thing again, which confuses me every time I do it, but there we are. Anyway, so that's how that works. So what I'll do now is I'm just going to change this link across to say that we're not, if I can get it in shot here, to say that we're not using the 7-segment display. We'll unplug the display from it. Or actually no, I'll leave the display plugged in because we can use the display to actually monitor what's going on those lower numbers. So let's just pop that link onto there, stick that back out of the way, move this back into shot. Now we need to restart our serial session because that will cause the controller to reset. We might as well clear all that MIDI as well. So we'll just start that again. So that means now, because that's reset, it will have scanned everything and it now knows that we are no longer using the display. And the proof of that really is that if I can kind of shade it out a little bit from the light, it's not lit up at all. Okay, so there are no segments of light on that display. What will happen now is that if I'm on channel 11, which I am, as I switch the notes on and off, and this is going to be quite tricky, I think, to make it visible. Maybe that will do it, I don't know. But if I start with note 0, hopefully you can just about see. How am I going to do this? Wait a minute, let's turn that main light off. Does that help? Does this help? Not really. Okay, so we'll put that one on and we'll try turning that light off and see if that helps. Oh yeah, that's a bit better. Okay, so note 0 is that top segment, and as we move up the display you can see they go on sequentially around all the different segments, and obviously what that's doing is that it's lighting or powering these LED outputs at the bottom. So just to prove that, if we take our little test lead here and we connect this to number 1, so we got our LED there now. When I do note on number 1, absolutely nothing happens. Hang on, where are we? Right, that's because I've still got the display plugged in, so let's get rid of that. Right, that's more like it. So now, note number 1, obviously note on, note off, you can see that. And then 2, 3, 4, we don't see anything, but just to prove things, so it's 1, 2, 3, 4, 5, let's do number 6. So if we do a note on 6, 1, 2, 3, 4, 5, 6, there we are. So LED goes on and LED goes off. And we get the display on the serial output here as well, just showing the notes that we've done and the fact that they're either on or off. So as it says, aux function 7 on, 7 off, and so on and so forth as we go through. So that's it really. That's what the aux board is for. If you don't need a display and you don't need any LEDs or anything or any extra inputs, then you don't need the aux board. But if you do need any of those things, then this is just a kind of quick and easy way to get that MIDI data into some sort of control, or in from a controller into an indicator or something on your console that's hopefully going to allow you to cover the last bits and pieces that aren't covered, as I said in the previous video, by the previous boards that we've looked at in the previous videos. So that's that for this one. It's just very quick video. This 7-segment display board, just before we leave this, if I pop that out of the way and I put the other light back on, we can see that this side you've just got 4 mounting holes, which I think you can see 2 of there, and on the other side we've just got that socket. So the idea is that you would obviously cut a hole in the fascia of your console, and this is fairly deep. It's about, from front to back, probably about 12 millimeters deep. So you could recess this slightly from behind if you wanted the front to be completely flush, or you can get little plastic bezels from Amazon and places like that. These things are pretty much a standard size. There are 2 sizes. There's this one and there's the little ones. I can't remember the size. I think these are actually sold as 3/4 of an inch or something, rather than in their metric size. I think there's 1/2 inch and 3/4. This is the bigger one. So what I've done in the past is just mount the bezel onto the front of the organ console, cut out a larger hole behind, and then we just pop that into the hole, screw it into the wood, and then obviously we can just plug into the back end of it there and plug the other end into the board wherever that's mounted in the organ. So that's the idea. It's supposed to make life easier. Hopefully it does. That's all there is to say. So thanks for watching, and I will see you in the next video.